So this is the part 2 of discussing some questions on pipeline processor. So here we have this question which says, so make sure you watch the last video before watching this video. So here we have a multi-cycle processor which having an average CPI of 4.2 and a clock cycle time 800 PS. The instruction count is 3 into 6. This is a basic formula. The total number of instruction 3 into 10 raised to 6 into the average CPI 4.2 into the clock cycle time, that is 800 into. Now you have to understand this. What I was talking about is that this is just a basic question. You can just write it like this. There is nothing more to talk about here, but the next thing is that you have to stay tuned till the last question, because the last question is kind of important, and here it is said that it is multi-cycle. So that is why we have took the average CPI. Okay, that is another important thing that you have to note. In multi-cycle, we are not learning multi-cycle detailing in our syllabus. So but just understand that in multi-cycle you are taking the average CPI. Okay, so if in the question the average CPI is given, then you can take that. Fine. Now let's see. Sorry for the quality of these questions. I'm just sorry for about that. Now there are two processes executing the same program of 10. This is 10 raised to 6. I hope so. It's 10 raised to 6. Yes, no, it's 10 raised to 5, guys. It's 10 raised to 5. Fine. So 10 raised to 5 instructions. Their processor has CPI and clock value is given. Processor B's CPI and clock is given. Compute the execution time for both the processor. Identify which is the faster one. Which has the less execution time, that will be the faster one, right? You have to understand that which processor has the less execution time, that processor would be the faster one, right? That processor would be the faster one. If you have less execution time, only the time taken to execute is less, means it is faster. Then you can easily calculate the processor A's execution time using total number of instructions is 10 raised to 5 into CPI is 1.2 and clock is given to us, it's gigahertz, it is frequency is given, so you have to divide 1 by 2 into 10 raised to 9, like that you have to do, because it's frequency. So clock speed would be what? Frequency is given. Here in our equation it is clock speed, so it is 1 divided by 2 into gigahertz. Hertz, we know it is frequency. Similarly for process B, you will calculate what? 10 raised to 5 into. So here what you're going to do is the first you find the processor A, 10 raised to 5 into 1.2. This you have divided, you get 0.5. This you have found out as 60 millisecond, let us say. For processor B also we do the same thing. 10 raised to 5 into 1.5 into 0.33, you get 50 millisecond. Which has less execution time? Processor B. So if processor B has less execution time, like execution period, means processor B is the faster one. Okay. Similarly, there is another same question, that is there are program X runs on 2 machines it is running. Machine 1's instruction CPI clock, which is also in frequency, you have to divide for finding the clock speed. Again, machine 2's instruction CPI is given, which would be the better machine, means lesser execution time, that would be the more faster, so that would be the better machine. So again we calculate the execution time by the total number of instruction into CPI is given as 1.1, then you have to divide it for calculating the clock speed. You found out this. Again for machine 2 you are doing the same thing, total number of instructions, CPI, clock speed. Then you have noticed that 336 is smaller value, so that means machine 2 is the better here. Okay, now let's do this question. This is kind of important. A 5-stage pipeline process execute 500 instructions, 12 branches, 25 of branches are taken, and each taken branch flushes 2 cycles. Clock cycle time is given. Compute the execution time. Execution time, we know, is the total number of instruction into CPI into clock cycle time is given as 1 nanosecond itself. Instruction is given as 500. We have to calculate the CPI. CPI would be the current instruction plus 12 branches, 25 of these branches are taken, and each of these are 2 cycles. So how do we calculate this? That is you have to calculate it by multiplying the fractions, that is 0.12 into 0.25 you have to do, into the flush penalty, that is 2 cycle. This if you multiply their value, you get sometime like 0.06. that is the value that you're going to get here, right? If you want, you can check. I will just check it in my calculator. This is 0.12 into 0.25 into 2, you get 0.06. okay, so ideal 1 plus 0.06, you get 1.06. that you have to substitute in our CPI. Now you will be understanding this question. Here I have the part 2, I have did little bit faster the solution, because I have did the detailed solution in the part 1. okay, so therefore part 1 you have to watch. That is, if you check my channel, I'll just show you. You can see this COA pipeline question numerical. This is the part 1. okay, so just check out this pipeline first, this video, then check out this video. okay, thank you.